Good afternoon,
Good
sir.
afternoon, everyone. So this is algebra session, but not essentially algebra. There will be mixed puzzle type of problems, simple problems. Yeah, so we'll start with a puzzle based on again Ramanujan's life. Find positive integers x and y. Such that x plus root y is 7 and root x plus y is 11.
Good afternoon, sir.
Hi, good afternoon. Yes, as always, you can put your answers in chat box only to me. Don't disclose it for everyone. Or if at all you want to say something, you can raise your hand. Okay, so story about this puzzle is it's essentially system of simultaneous equations, and maybe Ramanujan was in 5th, 6th standard, and he was already famous in school as a math wizard. So one of his friends told that friend's uncle that my friend is a very good math wizard, and that uncle told, like, you ask him this question. Let me see if he can answer this. And the friend told Ramanujan this puzzle, but Ramanujan immediately answered within seconds. So that's the story of this problem. Yes, Chinmay.
Sir, I'm done.
Oh, okay. Yeah, you can put your answer in chat box, but only to me, not for everywhere.
Okay, sir.
Yes, right.
Is my
Yes,
answer
right.
correct?
Yes, yeah.
Sir, today I attended the BMTSC exam.
Oh, how was that?
It was nice. The duration was 2.5 hours, and it had 60 questions in total.
Okay.
I attended it online.
Oh,
Am I right?
yes, Chinmay. Very good.
This is the first problem only, na?
Yes. Generally, as compared to this NMTC, JMO, etc., I found that BM's TSC exam is little tougher as compared to others.
Yes, sir. It is harder than NMTSC.
Yeah. And it's more geometry oriented.
Sir, this problem was pretty easy.
Yes. And for Ramanujan, it was absolutely nothing.
This is quite a trivial problem, sir.
Yeah. In fact, Ramanujan in his life solved problems which are 100 times, 1,000 times tougher than this orally within few seconds. And for him, this was nothing.
I mean, here the numbers are small, so it's quite easy.
Yeah.
Or even if he knew the solution, what to do, he has to evaluate it, na. But if he has to evaluate, and if that is what do you call taking very less time, then he like just probably use some math tricks. Na, they use that Vedic maths goes say with the hands, they do some stuff.
Yeah, but actually, I guess Ramanujan had no education or no acquaintance with this so-called Vedic mathematics. In fact, it was much later than Ramanujan's period. Ramanujan died in 1920, and this Vedic maths, etc., it came into picture after 1930. Anyways, he has his own ways of counting, etc., or calculations.
Yes, sir. I think he should have a way like a trick.
Yeah. Okay, so let's start with this problem. Now, very first thing, shall I say from very nature of the equation that x and y, if at all they are integers, they must be perfect squares, right?
Yes, sir.
Because otherwise, this part is irrational if it is not a square. This part is irrational, and I'll get irrational number equal to 7 minus x, irrational number equal to 11 minus y. So on one side I get irrational, on other side I get integer, which is wrong, or in mathematical terms that is called as contradiction. Right? So very first thing, they must be squares. So let me call. So let's try to do it using algebra since we have developed algebra. So let root x be called as a, which is again integer, and root y be b. So where a, b are integers. All of you agree?
Yes.
Because we are assuming that x and y are perfect squares. So what this means, x is square of what? So this means x is a square and y is b square. So that root of x is a, root of y is b. All of you agree? Now we'll rewrite those equations again. So what are the equations? X plus root y is 7. And root x plus y is 11. So you can rewrite a square plus b is 7 and a plus b square is 11. All of you agree?
Yes, sir.
So I'll subtract. What shall I do? I'll call this as 1. I'll call this as 2. And what I'll do is 2 minus 1. Implies b square minus a square plus a minus b is equal to 4. Again, we know factors of b square minus a square. Who will tell?
Sir, a plus b, a minus b.
Yeah. So this is a plus b into a minus b. Sorry.
Then it's b plus a multiplied by b minus.
Yeah, so b plus a into b minus a. And just to get b minus a factor, shall I take minus sign common from these two? So minus b minus a. All of you agree with that?
Yes, sir.
So now I'll take b minus a throughout common. And from first bracket, I'll get b plus a. From second term, I'll get minus 1. So b minus a plus b plus a minus 1 is equal to 4.
So, Akhilya, send the answer.
Yeah.
Can I tell my method?
Yes. Yeah. Amit, after I complete, you can tell your method also. Okay.
Sir, I'm
Either yes.
So,
Uh,
can I also tell?
After I
Sir,
finish,
can I also tell?
just a minute, one by one. After I finish, you can tell one by one. Okay. Amit, Aitreya, who else?
Sir, me, Chinmay.
In my yes. Yeah. So this means, shall I go to next page?
Yes, sir.
This
Yes,
means
sir.
b minus, now they are integers. So b minus a must be, say, 2 and what was that? b plus a minus 1 also must be 2. That's one case. Or b minus a, the smaller number, must be 1, and b plus a minus 1, the larger number, must be 4. So that's how we get product as 4. How do we solve this system? Add the two numbers, add the two equations. A minus a cancels. So I get 2b equal to, or 2b minus 1 equal to 4. So 2b equal to 5, which means b is 5 by 2. But already we know a, b are integers. And in this case, I get b as fraction, not an integer. So my a and b are integers. Check here, right? So this is not the possible options or correct option. So this does not give required solution. So let's solve the other one. In this case, if I add again a minus a cancels, so 2b minus 1 is 5. So 2b is 6. So b is 3. And once I get b as 3, I can put anywhere here or here, and I'll get value of a to be 2, which means our original x and y are x is a square, that is 2 into 2, 4. Y is b square, that is 3 into 3, 9. Okay, so solutions are 4 and 9. Yeah, of course, you can do it by easier method, but I wanted to explain algebra in solving.
And if you use b minus a equal to 4 and b plus a minus 1 is equal to 1, then you'll get negative answer, right?
Yes. But our a, b are positive integers.
Yeah. So it's just 1 second.
Yeah, now one by one, Amit, Aitreya, and Chinmay, you can explain your solutions one by one.
Sir, what I did is I thought that they are the numbers, like they are smaller numbers, as they are 7 and 11. The sum should be either 2-digit number plus 1-digit number, or 1-digit number plus 1-digit number. As they are 1 digit, I thought of taking 1-digit numbers which are perfect squares. So I got 1, 4, and 9.
Okay, yeah.
So I took 1 as x, square root of x. So x will obviously be 1. So then the other number will have to be 10, and 10 is not a perfect square, so 1 is deducted. And then I took 4 and 9. I thought x can be I thought x can be 4 because
Just a minute, Aitreya, shall I go back to first page?
yes.
So that, yeah, so problem will be in front of me. Yeah. So let me just comment. So what Aitreya was saying was, like, from this equation, x and y must be perfect squares of single digit, right? And then you try, so what are single digit squares? 1, 4, 9. So you try possible combinations of x and y. Okay?
What if the numbers were big?
So if numbers are bigger, you have to take help of algebra, the way we did. Yeah, Saket, just see one more point. Like suppose if AB are any numbers, real numbers, then you see there are infinite many solutions from this, right? Because product of two numbers is 4, and if they are not integers, there will be infinite many solutions. Because they are integers, they have only finite many solutions, namely this.
So you can plot it on graph also.
Yes.
You can plot it on graph and wherever it intersects.
Yeah, so
I'll
graph
put it on the
will be hyperbola.
So yes. Then if x is 9, then x plus square root of y will not be 7. It will be bigger number than 7. So I took y as 9 and x as 4. So it came out to be
Good.
correct.
Great. Amit, how did you do that?
Sir, I didn't exactly have an algorithm, or I didn't have a proper way of solving it. So can I explain the next one?
Yes, yes.
Sir,
Chinmay, yes.
sir, probably I done with the same, but lastly, when I had not checked the all combinations, I just clicked 4 plus 3 is equal to 7
Okay.
and 9 plus 2 is equal to 11.
Okay.
But it was similar to I3.
Yeah. So everyone got it? Should we go ahead?
Sir, wait, so same solution as who?
Saket, yes.
Sir, I put it on graphing calculator, and it said that there's only only one intersection was there. So can I just check chat 1 second?
Yes.
Over there, I sent it. Only there's one intersection. So how are they infinite solutions?
If there are what do you say, like suppose x and y are real numbers.
Yeah.
In that case, in fact, from equation you see. So let's see, for example, I have product of two numbers as 4, and they could be any real numbers, right? So product of two numbers is 4. So let's say I will have xy equal to 4. It's a hyperbola. And you take anything. So you take x as anything. Y will be solution. Then you take this as x. This y will be solution. You take this x. This y will be solution. If they are not integers, then if there is no condition of integers, there will be infinite many solutions.
But there's only there are two equations. No, if you have to satisfy both equations, right? No, there are infinite solutions for x plus root y is equal to 7, and infinite solutions for root x plus y is equal to 11. But what about both of them? You said both of them have to be true, then only one intersection will be there, na?
Oh yeah. So satisfying both, right? Yeah. So in that case, after getting this final solution, we should check whether this 9, 4 satisfies given condition, and that really satisfies. If I put y equal to 9, is equal to 4, that really satisfies these two equations, right? Yes, Ari, thank you. Okay, so shall we go ahead?
Yes.
Find ten positive integers such that their sum equals their product. So I want some 10 numbers, A1, A2, A3 up to A10, such that their addition should be same as their multiplication.
Like digit, what digit?
Yeah, they could be single digit numbers. No problem. What I would suggest is, so you first do it for 2 numbers. And once you get the idea, you do it for 10 numbers. So find two positive integers whose sum equals product. Okay. Once you get the idea, you can do
So
it.
different or same?
Uh,
So can it be same? Like can few numbers be same?
yeah. So they may not be distinct. Once you get it for 10 numbers, even you can do it for 100 numbers, 1000 numbers, anything.
So they can be same, right?
Yes.
Sir, I got it for the two numbers. It's 2 plus 2 equal to 4.
Don't disclose the answer.
Sir, I got it. Can I send?
You send in chat box. Okay.
Sir, numbers can be
Have you
same.
got it for 2 or 10?
Sir, numbers can be same, right?
Yes. Yes, Naitik, good.
So Saket, the one I answered.
Yes, sir.
Sir, even I sent
Or
my
we can use that what do you call what's it called? Those special numbers with there's a name for it, na? Wait, where the factors sum is equal
It's
to
a perfect
Perfect
number.
numbers.
Either you have taken example with twos, but then product will be 2 raised to 10. It won't be 2 into 10.
product.
We want sum to be equal to product.
Sir, didn't get it. Sir, I didn't get it. Can you tell it?
See,
That?
suppose I have two numbers. I want, say, A and B. I want A plus B equal to A into B.
Oh, okay.
Like that, we want 10 numbers such that A1 plus A2 plus A3 up to A10 is equal to A1 into A2 into A3 into A10. Product of 10. Okay, so let's see the algebra part for two numbers.
Sir, 1 minute. Sir, 1 minute. I just.
Okay.
Sir, I set my answer in the chat.
Just a minute. Huh? That's good. But can you give something other than 0? I should have mentioned non-zero. Already I mentioned positive integers. I don't want 0, positive integers.
Oh.
Okay, so let's do it for two numbers first. So suppose those two numbers are a and b. What we want is a plus b equal to a into b. Okay. Now, what I'll do is take all terms on one side, ab minus a minus b equal to 0. Now, of course, this has no good factorization, but if I add 1, which you can guess by practice, then then you have nice factorization on left hand side. From these two terms, I can take a common into b minus 1 minus, I'll take minus common into again b minus 1 is 1. So I get a minus 1 into b minus 1 equal to 1. And they are integers. So product of two positive integers is 1. And only choice is this must be 1 and this also must be 1. Which implies a must be 2, b must be 2. So I say 2 plus 2 is 2 into 2. Right? Now whatever we are doing here for two numbers.
Sir, how did you like get how did b plus 1 become b minus 1?
Oh, sorry. Have I made something wrong? Just a minute.
Sir, below that also it's b minus 1.
Yeah. It will be b minus 1.
It's right actually. When you take the minus sign common, b minus 1 is correct, sir.
B minus 1 is correct, but here I have done something wrong. Yeah. So this should be b minus 1, right? And then I get a minus 1 into b minus 1 is 1. So a minus 1 must be 1, b minus 1 must be 1, right?
So how is it b minus 1?
Because they're putting in the brackets, that's
See,
why.
now this minus b plus 1, I'm taking minus and common out of those two terms. So plus becomes minus, minus becomes plus, right?
Opposite of opening the brackets, that's why.
Yeah.
Okay.
Okay, so this is for two numbers. Now try to do it for 10 numbers. You can put your answers in chat box. But don't disclose the answers. You can write it only to me. So very first thing.
Sir, can the two numbers be the same?
What did you say?
Sir, can the two numbers be the same?
Yes. For example, in this case also we have got both numbers to be same.
Okay, sir.
Yeah, so see that one thing is clear. If my numbers are something like 2, 3 and so on, do you see the product will be much bigger than the addition? So I should take maximum numbers to be 1 if I want product to be smaller enough as addition, right? So possibly there will be more than one solutions, but let's try one case or one solution. So suppose if I take as many possible numbers as 1, 1, 1. So let's take, say, two number. Now this is for 10 numbers. Just a minute, somebody has put answer in chat box. Yes, Amit. Yeah.
I got it.
Sir, I was going to put 1, but I thought that was like without any sense.
Sir, I got one solution.
Yes, okay, good.
So how many solutions are there?
There will be many solutions because I have choice about this, how many ones I should take. I can take maybe possibly 8 or maybe 7 or maybe 6 and so on.
Okay, yeah.
In fact, if you are doing programming, you can write a program in Python to find all possible solutions of it.
But there's no infinite amount of solutions.
No, there will be finite. Now, how many I have written? 5, 6, 7. So let me take 8 ones, and like earlier case, let me take two numbers of my choice, A and B. So I want 8 plus A plus B to be equal to A into B, because product of all these numbers will be 1, right? So I'll have something like 8 plus A plus B equal to AB, which means 8 equal to, shall I write it this way? AB minus A minus B equal to 8. I don't have 0 this side, I have 8 this side. Same case, whatever we did in earlier case, we'll do same thing. So AB minus A minus B, I'll add 1, right? Equal to 9. I get A minus 1 into B minus 1. Is that right?
Yes.
Equal to 9. I can take A minus 1 as 3, B minus 1 as 3. So A is 4, B is 4. So I get 8 plus 4 plus, so if this is 4, this is 4. 8 plus 4 plus 4. So sum is 16 and product also is 16. Right?
Sir, we can also take AB as 1.
Or you can take A minus 1 as 9, B minus 1 as 1, and that will give you 10 to A is 10, B is 2. So in that case, product will be 20, as well as sum will be 10 plus 2 plus 8. That will be 20 again, right? Yes, Nike.
I have a question. So in the first step, how did you know you had to put 8 ones? Like,
No, it's just trial and error. So this is not the only way or only solution. There will be many choices. But what I said was, like, if I want product to be equal to sum, I should take many ones, right? Because if my numbers are more than 1, product will be larger than the sum.
yeah.
Was the idea.
Okay. Thank you.
Okay, shall we go ahead, all of you?
Yes, sir. Back just 1 second.
Yes.
Okay, yeah, so got it.
Alice and Bob, it's a puzzle. Alice and Bob are playing a game. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . are playing a game. There are some candies with them initially, and whoever loses the game gives half the candies to the winner. Okay, so suppose, for example, I'm Bob, and suppose initially I have 10, Alice also has 10, and if I lose the first game, Alice is the winner. Then what I'll do is, whatever candies I have, half of that, so that is 5, I'll give to Alice. So Alice will be having 15, and I'll be having 5 after the first game. Is it clear?
Then what
So
if it's odd number again?
So numbers will turn out to be even actually at every step.
How, like if it's 10, like if
So you can take
A
12.
loses-
So 12
Yeah.
policy.
Yeah.
sir, if A loses twice, then how, like if you have 5 candies, then how much will you give?
So those numbers will be arranged such that you don't have to break candies into half or something. There will be whole numbers. Yeah, I just explained.
Power of
if
2.
we come to the
I just
so
explained
if
like
we come to 1,
what's the rule. So whatever candies I have to give half of my candies to the winner.
sir,
I
if
just
we come to 1, then what should we do?
so you
If
have to break
someone,
it. If you have odd number, you have to break it. So like suppose, for example, I have 5. I'll have to give 2.5 to the winner.
okay, sir.
But I hope most probably they'll be integers. You don't have
Sir, what if we have one candy left and we already broke it into half, and in the next round also we lose, then we have to break that half candy into another half.
Yeah. Let's see the puzzle. How far we have to go. Yeah. So Alice won the first game. Then Bob won the second game. And again, Alice won the third game. After 3 games, after these 3 games, so once they give half of their candies to the winner and so on, after 3 games, Alice had 33 candies. And Bob had 15. How many candies did they have in the beginning?
So this is very easy. Ramanujan can solve it in a second.
Yeah. It's a puzzle, sir. Generally, puzzles are.
Calculating backwards.
Yeah.
Yes, I thought of that.
But don't disclose it. You can put answer in chat box.
So I feel like you've given this problem before, sir.
I don't know. Have you solved?
Yes, I think you've given this before.
Okay, okay. Do it again.
I sent in the chat. Saket.
Okay. I just suck it. Good.
Sir, इसमें also correct.
Vijay Krishnan, yeah, correct.
So, sir, તમે correct, sir, Johan.
Yes, sir. Yeah. I mean, Bob's number is correct. Eddie's number, I don't know, perhaps it's typing mistake or something.
Okay, sir.
Bob is correct. Eddie's is.
Wait, sir, if someone got one of them correct, then the other one they can just subtract the sum from the sum now.
Yeah, so I think it must be typing mistake or something. Yeah, shall we start working? You feel you can do it and you want some time? 1 or 2 more minutes?
Sir, can you wait for 2 minutes?
Yes, yeah, yes, yes.
Sir, I just want to have one question.
I just submit.
Sir, Alice's number that I wrote is wrong, but Bob's number is correct.
Yeah, Bob's number is correct.
So Alice's number is wrong.
Yes. So I thought initially it might be some typing mistake or something.
Sir, but sir, how's it wrong? Sir, because at the end, Bob and Alice both have 48 candies, and the number that I wrote, if you add them as well, it should come to 48. And if Bob's number is only correct, then Alice's number should be either no, the total candy should be increased or decreased.
Alice number here written as 20.
Yes, sir.
So how much is the sum? Sum is not 48.
So it's for 20 plus 24 is 48. Oh, sir, I typed it wrong. So one second.
Yeah. Okay. So let's make columns. Alice has some candies initially, and Bob has some candies initially. And after the first game, so who won that first game? Alice won the first game. Bob will give half of his candies to Alice. Right? Then we'll write down those answers after the first game. And then after second game, so second game is won by Bob. So Alice gives half of her candies to Bob. Suppose those two numbers are these. And after third game, again Bob gives half to Alice. And Alice has, what is that number? Alice has 33 and Bob has 15. Right? So what is the number before the third game? Obviously, if Bob has 30, then half he'll give to Alice, that is 15, and therefore he is left with 15. So whatever number
So 33 minus 15 would be 18.
so whatever number he is left with, exactly double he has before the game, right? All of you agree?
Yes.
Yeah. So Bob must have 30 initially, and Bob is giving 15. So after giving 15, the number is 33. So how much Alice should have initially? It must be
18.
right. So 18 plus 15 is 33. So for good. So this is situation after the second game. And how Bob gets 30 and Alice gets 18 after the second game. So again, Alice must have 36 and she loses. So she has to give half to Bob. And therefore she is left with 18, right? Double of 18 is 36. So she must have double of 18 before the second game.
Sir,
Yes.
sir, in my calculation, I wrote 18 plus 18 is 32. So Alice and Bob should be both having 24.
Yeah. And after getting 18, Bob has 30. So Bob must have 12 before the game. Right? So this is situation after the first game. And first game is won by Alice. So Bob has to give Alice half of what he has. So Bob must have 24, double of 12. Right? And after getting 12, Alice has 36. So even Alice must have 24. So it's a fair game. Initially, they have equal number of candies. So let's say check it once again. Alice and Bob both have 24. Alice won the first game. So Bob has to give 12 to Alice. So after the first game, situation is 36-12. Second game is won by Bob. So Alice has to give half, that is 18, to Bob. So after the second game, Bob will have 18 plus 12, 30. Alice will have 36 minus 18, 18. And now third game is won by Alice. So Bob has to give half to Alice, that is 18 plus 15. And Bob will have 30 minus 15. So this is 33, this is 15. Now you see, as far as puzzle is concerned, they play only 3 games. But if at all they want to continue after this game, they'll have to break the candies into half. Okay. So far good? Everything is fine?
Yes, sir.
Yes, sir.
Have you go ahead?
Yes, sir.
Yes, sir.
So can you just go back just 1 second?
Yes.
Yes, sir.
Yeah, I forgot. Saket, Aitreya, do you have the same thing, same working?
Yes, sir.
Okay.
Yeah.
We did the reverse calculation.
Yeah,
So-
basically reverse calculation. We can put it with anything. We can put with A and B also. Like we can make P and Q instead of 33 and then we can take P by 2, 2Q, etc. etc. We can do.
Yeah. So how I did was essentially backwards calculation with the fact that whoever loses must have double the candies before the game. Yeah, let's go ahead. Now I have some puzzle based on common sense. It's not actually math problem. Find positive integers x, y, z such that 29x plus 30y plus 31z is 366. Again, as far as maths is concerned, if you have one equation and more than one variables, possibly there could be more than one answers.
Sometimes if it says positive integers, then there might be only one answer also.
Yeah, but
Sir,
in this case, answer is more uh, based on common sense rather than mathematics.
no, sir. Sir, I found my answer. Sir, it is based on.
Don't tell the answer. You can write it.
Sir, actually, I solved it as 365, not 366, but still, these
Okay.
are the same.
For 365, you must have 28 there.
Yes, sir, 28 only.
So this looks rather nicer equation 29, 30, 31. Yes, I think good.
Sir, this is based on common sense. I now understand.
So how can we use common sense to solve this?
Yeah. So I mean, there is.
You'll see it later if you think it carefully. It's general.
I mean, there is no mass involved. So that's what I mean. If you want to get one obvious solution.
Oh, okay. Wait. So something in the chat.
Yeah. So all of you can put answers in chat box, and I want lot of answers. Everyone should get it. Yes, I do.
Press enter in the chat.
Sir,
Wait,
can
sir,
you check?
sorry. Ignore that, sir. Ignore.
Yeah.
Sir, can you check mine?
Yes, Chinmay, correct. Yeah, good.
Saket?
I have to check this. Just a minute.
Yes, it's coming for me.
Just a minute.
Oh, yeah. To make it all positive, just 1 minute. Let me just make it positive.
Yeah, this is working, but 0 is not
Yeah,
positive.
yeah, okay, sir, I changed it. Sir, is this?
Okay, this may not work because you reduced that 31 wala 6 by 1.
Wait, sir, let me just check again.
I added 1 for 29.
That is my answer, right?
Yes, Achyutan, I think so.
So is my answer correct? Type 3.
Yes, I agree. Yes. Okay, so as I said, it's more common sense, less maths. So what I want, what I have in mind is, in fact, these are number of months with 29 days, 30 days, and 31 days, and it's a leap year, so we get 366. So February only has 29 days, and which means X should be 1. Then there are 4 months with 30 days. So April, May, June, July, August, September, October, November. Right? And there are 7 months with 31 days. So together it gives 366 days, days of a leap year. In fact, original problem where I saw was 28, 30, 31 equal to 365.
Yes, sir, even I solved that one only.
Yeah. But 29, 30, 31 looks more in pattern.
Yes, sir, because plus 2 plus. No, 29 one looks more pattern because 29 plus 1 30, 30 plus 1 31.
Yeah, so they are consecutive numbers.
But by the way, if we solve 28x, that one you'll get more, like you'll get more confused because 28, how should I say, like it, you may get confused like which month, which month, which month.
Yeah.
So,
So obviously those who have put other
I got the
solutions,
exact same answer, but I didn't do it using this.
yeah, those who have put other solutions, that's fine. But what I had in mind was this solution, something based on
so
Like,
calendar.
like my solution, the exact same answer I got, but I did it little bit more mathematically.
Mhm.
So basically, 366. Let's approximate it to 360. Okay.
Mhm.
And then we have 29, 30, 31. Let's fill the constraints first. Okay, but before that, 360 is equal to 30 into 12, right?
Yes.
So we want to put 12 30s. So that's 0, 12, 0. But because we want to like have one for each, at least we can take 1, 10, and 1. Okay, now that will be equal to 360. Now,
Mhm.
but the problem here is we want 6 more. So we can replace, we can subtract 6 from 30 and add 6 31s, which will add plus 6. So we get 1, 4, and 7.
Yeah.
Yeah. That.
Amit, what did you want to say?
sir, I got an answer. Uh, Sir, I got X, Y, and Z all equal to 366 divided by 90.
366 divided by
90.
But provided x, y, z are all equal, right?
So I can, yeah. Sorry.
Yeah, so something like, suppose if x and y and z are all equal, then you can take numbers common and you will get something like this. But then x won't be integer because 90 won't divide 366 completely.
Oh,
So x won't be integer in that case,
yeah.
right? Yeah, so once again, those who have got other solutions, they may be correct. And there is no nice method to solve such equation with 3 variables. Just trial and error, that's it. But this is something obvious based on calendar. You don't have to work much. Yes, Srishta. Yeah, good. Amit, your solution also is correct. Only thing we want integers, so it may not work. Okay, but otherwise,
So when I saw the question, sir, I only saw the equation and I directly gave the answer. I didn't see any details.
yeah. Shall we go ahead?
Yes, sir.
Okay, one more similar kind of equation, but with now one variable. So solve for x. When rather than working systematically, try to guess answer. That's better. X minus 6 by 2020 plus x minus 5 by 2021 plus x minus 4 by 2022. That is 3. I want value of x.
That is my answer, right?
Yes, actually. So look at the pattern. Your numerator goes on increasing by 1 as well as denominator goes on increasing by 1.
Sir, is mine correct?
Yes,
So
ma'am.
what are the previous problems? I just went to the
Sir,
washroom.
ignore the
What are
first
the
one.
previous
It was
problem?
the printing mistake. Is mine
Yes,
correct?
actually, yes, correct. Second is correct.
So what was the previous problem? So I went to the washroom, sir.
No, this is the problem. So earlier page was this.
Okay, sir. Oh, sir, I got the answer already, sir.
And you can put in chat box. Yes, Sati. Yes, a nice observation here is there is
Sir, is my answer right?
pattern in numerator denominator both go on increasing by 1. Okay, so possibly if I can make this as 1, then all answers will be 1, 1, 1, and therefore sum will be 3. Fine. So for example, I can put x equal to 20, 26, and I'll get 2020 by 2020 plus 2021 by 2021 plus 2022 by 2022, which is 3. Okay. And how many solutions will have?
Sir, I think it's only one solution.
Yeah, good. So
Sir, I
basically,
thought that
Sir actually did it in a different method.
Sir, I thought that we should find the LCM of 2020, 2021, and 2022, and then we should subtract them, and then I got confused, and I thought,
yes, that will be lengthy and tedious as
yeah,
far as calculation is.
that's right.
Sir
So in
actually
fact,
did it in a different method.
yes, Vijay.
Sir, it's like x minus 6 by 2020 plus 1 plus minus 1 plus x minus 5 by 2021 minus 1 plus x minus 4 by 2022 minus 1. That gives us x minus 2026.
Oh, good, yeah. Very good.
And I took x minus 26 in common, and 1 by 2020 plus 1 by 2021 plus 1 by 22 gives 0, sir. Then 1 by 2020 plus 1 by 2021 plus 1 by 2022 cannot give 0. So x minus 2026 must give 0, sir.
Oh, very nice, very nice. Yeah.
So
So,
actually, this a similar sum came in NMTC stage 2, sir, this year.
oh, acha, acha. Okay, let me write what you are saying. X minus 6 by 2020. And this 3, I'll take on this side as minus 3. And I'll distribute it as 1, 1, 1 to 3 parts. Or it's like subtract 1, 1, 1 from each term. And this side I'll get 0, right?
Sir,
This
yes, sir.
gives x minus 2026 by 2020. X minus 2026 by 2021 plus x minus 2026. So you are making numerator common. Good.
Yes, sir.
Okay, shall I go to next page? Just for writing this.
Yes, sir.
If you want, I'll come back again to this page. Okay, so what Vijay did was subtract 1, 1, 1 from each term, and on the right side we get 0. Fine. So that your numerator becomes common. Same. So I can take it common, x minus 2026 times 1 by something, 1 by something, 1 by something, right? And this is equal to 0. So which means either this term is 0 or this term is 0. But this is surely not 0, right? And therefore this has to be 0. X minus 2026 must be 0. So x must be 2026. Good. Anybody has some other argument?
Just notice denominators going up by 1 and the numerators going down by 1. So that just means like 1, 1, 1. Na?
No, numerator also is going up by 1.
Numerators going. Yeah. Sorry. Yeah. Numerators also going up by 1. Therefore, for like it to be equal, it can just be same.
Yeah. In fact, that's how I thought, but this method is better, subtracting 1, 1, 1 and making numerator common. That's good. Okay. One more puzzle. When a 4-digit positive integer is multiplied by 4 as answer, what we get is its digits get reverse.
Oh, those type of GMO kind of problems.
Yeah.
At least 3
What?
questions in GMO with this.
Yeah. What is original number? What is original number? Maybe I can convert in a more convenient fashion. So suppose that original number is say ABCD, 4 digits. Okay. And what's given is when I multiply this by 4, my answer is DCBA. All of you agree? So it's like now cryptoarithmetic, cryptogram.
That is my answer, right?
Yes.
So one day you said module 2 you gave this problem as a homework.
Oh, is that so?
Yes, sir.
So that time had we solved it?
What, sir?
That time did we solve it?
Sir, I tried it. I got the answer. I remember it, but I didn't remember how I did it.
Yeah, that happened. Once I explain someone, they're like, you just solved the problem before, and I'm like, no, no, no.
Oh, acha. Yes, somebody has written some answer. Chudan, that is correct. Yeah, so first of all of you agree that this conversion is fine? Whatever question was given in words, I've written in terms of symbols. So suppose that number is ABCD and multiply by 4, digits get reversed, right? So 4 into D gives me A and maybe some carryovers, right? But shall I say A must be even? Okay. But A is even means A can be 0, 2, 4, 6, 8. Now surely A can't be 0. Why? Because otherwise it won't be 4-digit number. It will be 3-digit number. So A can't be 0.
Sir, then B also, like it, B, if we add B to A, I mean, if like the multiplication principle of 4 is the last 2 digits have to be divisible by 4. So we have to find a number B which is divisible by, like if we put it near A, it will be divisible by 4.
Yeah. Okay. I have something more to say. A can't be 4, 6, or 8. Why?
Because then if A would be 4, 6, or 8, it become a 5-digit number.
Yeah, so if I put A as 4 or 6 or 8 here, and if I multiply by 4, it will be 4 4 is 16, 4 6 are 24, 4 8 are 32. It won't remain 4-digit answer, it will be 5-digit answer. All of you agree? So that fixes A.
Yes, sir.
That fixes A. A must be
Is
2.
equal to 2. Sir, if A is 2, then B must be 8.
So A must be 2. Okay?
Then D could be 3 or 8.
Let's see. So shall I go to next page and rewrite problem? So we have 2 BCD into 4. 2 BCD into 4 is equal to
Sir, can you again tell how A is 2?
just a minute. Okay. So 4 into D gives me last digit as A, and it's a multiple of 4, so it must be even, right? So A must be even.
Yes, sir.
So it can be either 0 to 4, 6, 8. It can't be 0 because if A is 0, it won't be 4-digit number. It will be just 3-digit number. So A can't be 0.
So
Yes.
that B can be 1 or 3. Like if you put 1 on B, near B, so it will become 12. Like the last 2 digits have to be divisible by 4 if the whole number has to be divisible by 4.
Yeah. So yeah. So just a minute. So I was telling Chinmay why A should be 2. Yeah. So A can't be 0. Chinmay, do you agree with that?
Yes, sir.
Yeah. And further, I claim A can't be 4, 6, or 8 because if A is either 4 or 6 or 8, when I multiply A by 4, I'll get 1 or 2 or 3 as carryovers. So answer will be 5-digit, not 4-digit.
Oh, okay.
See, my answer is again 4-digit. It has to be.
Yeah, understood, sir. I understood.
So we didn't even need to know it can be 6 and 8 because even 4 into 3 it will carry over, na? So
Yeah.
that will be 4 into 2 maximum.
And it can't.
Saket, I did not get you. What you are saying?
Sir, we didn't even know it could have been 6 or 8 or 4. Even if it is without the odd condition, even if 4 multiplied by 3, that also still carry over. So it can max.
Yes. So, but in that case, it could be either 1 or 2, right?
Yeah, I know.
So A must be 2. All of you agree?
Yes, sir.
Yeah. Now 4 into what will give me 2?
Sir, 4 into 8 or 4 into 3, sir.
So D could be
Sir, but D
either
must
3
be 8,
or
sir.
8.
Sir, but D must be 8.
Why?
Sir, because 4 into 2 gives D, that means it should be 8.
No, but 4 into 3 also is giving me 12. So that will also give me 2.
Sir, no, sir. No, I'm
Oh,
saying that
at the end. Okay.
the last
Not giving any
thousands
digit
digit.
3.
Oh, yeah. So D, yeah. So do you agree either D should be 3 or 8 from this first calculation? 4 into D is ending with 2. And lastly, 4 into 2 will give me D, right?
So it can only be
So it can't be 3, it has to be 8.
8.
All agree? Yeah.
Oh,
So
so we didn't even have to know 3 or 8. We could already just use that information.
So shall I rewrite a second step? So 2BC8 into 4 gives me 4CB2.
So we can put carry over. 4 into 8 is 32.
4 into, yes,
Yeah, so we can put 3 carry over.
so 3 carryovers.
Sir, C has to be 1.
Why is that so?
Sir, because if a number is divisible by 4, the last 2 digits have to be divisible by 4. So in the end it is 2, so it has to be 3 because 4 8s are 32.
Oh yeah, number is divisible by 4. So you mean to say B2 should be divisible by
4.
4. So it could be either 12 or 32 or 52 or 72 or 92, right?
Yes, sir.
Yeah. And how will we get some of those numbers? So C has to be
Either 1 or
so if C is 1 and I get 72, right?
So that means B is 7. Sir,
So,
but it
so
doesn't
let's try
combine.
this. Let's try this. So if I take C as 1, so 4 8s are 32, 3 carry overs, 4 1 are 4 plus 3 is 7. Now
Sir, actually, if B is 7, then it would be
1.
28.
So 4 into something should give me.
Sir, but that means we'll have to change A.
Sorry. So this gives me B as 7, right? B as 7.
Yes,
So
sir, then it would be 28. Then the D must
Yeah,
be
so
changed.
C doesn't like 72 will not go. It has to be
yeah.
some
So
other
C,
Yeah. Oh, so
so
now
C
we can
equal to
say
1 does
that.
not work. C
So
equal
now
to
we
1
can
does.
say that B can maximum be 2, because if it is any more than that, it carry over and it won't be 8. So therefore,
Yeah.
we can say it can be 1, because
Yeah. So
all are
B
distinct
must be 1,
digits.
right? Yeah.
Because all are distinct, right?
But it can be 0.
Yeah. Even if it is not distinct digits, it will still be 1, because um because 4 into C plus 3 will always be odd. Because 4 into C will always be even, plus 3 will always be odd. And if B is the last digit, B also always has to be odd. And because we know it's either 1 or 2, it has to be 1.
Right. So B must be 1. All of you agree?
And
Yes.
then it's
Sir,
Sir,
why,
but
sir?
then A will change again.
B is
A will
1.
change to 4.
Sir, can
Sir,
B be
why,
0?
why B should be 1, sir?
2 and 2. No, it's 1, because if it is, it cannot be 2, because 4C, like if you multiply 4 into
It
C,
can
4
be
into C
0.
is always even, and even plus 3, which is odd, is going to be odd, right? And if it is
Yeah.
ending with B, we know B also has to be odd. So therefore B can't be 2, it has to be 1.
Yeah.
Yeah, got it. Yeah.
Sir, so the B will be the last digit. I mean the units digit of some 2-digit number, because you can't get C to multiply with 4 and add with 3 to get 1.
Yeah.
Sir,
So
can't
now,
be taken
now
as
so far is it good? So it's something like 21C8 into 4 should be 8C12, right? All of you agree up to this?
Sir, I'm not getting why B should be 1.
Okay. Yeah. So once again.
Sir, but if B is 1, then A can't be 2.
Why? A already we have fixed. A is 2.
Because if we put D as 1, 4 times D equals 4. See, 4 times 1 equals 4. And then just, so the answer would be reversed. So A would be 4 then.
Why that affects A? Because 4 into B is C. It won't be A, right? Anyways, all of you have reached up to this 2BC8 into 4 is 8CB2. Okay. Now, what he says is if B is 3 or more, we'll get carryovers and we won't get 8 here because 4 to the 8. And if we get some carryovers, we are into trouble. We won't get 8 here, right? So B has to be something smaller than 2. Right? Again, if B is 0, just say if B is 0, I get 20C8 into 4 equal to 2. Here I'll get 0, C8. Okay. But you see 4 8s are 32, so there is 3 carryovers. Then 4 into C will be even number. 4 into C is even number plus 3. That gives me something odd. It won't give me 0, right? So B can't be 0. Chinmay?
Yes, sir.
Yeah. So we'll try B equal to 1. There is no other choice. So it has to be 1.
Yes, sir.
Sir, I got it, sir. That means C is 7.
Yeah. Again, C must be in fact something larger so that we get some carryovers, right? So 4C plus 3 should end up with 1. Should end with 1. What is that? So 4C should end
Sir,
with,
it must be, sir, 4C must be 8
so C should be,
or 28.
so C should be 2 or
7.
7, right? Of course, you can try 2 and check that 2 won't work. So let's try 7. 4 7 are 28 plus 3, 31.
31.
Carryovers. 4 1 the 4 plus 3 is 4. Is 7. So that matches with our earlier C.
Yes, sir.
Yeah, so that solves the question. So 2178 into 4 gives me 8712. So digits gets reverse, right?
Sir, and I also remember you asked us a question in class in the class that in module 1 that a 2-digit number is there and its square will be a particular number, and if we reverse that 2-digit number and find its square, it will be the reverse of the original number square.
Okay.
And then we got it that the number is 13. 13 13s are 169. 31 31s are 961.
Yeah, 960. Yeah. Okay, so let me quickly give one question and we'll stop then. So you take it as homework. It's a simple question based on patterns. Observe the pattern. Tell me the answer tomorrow in the start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on. And so on. So this is my first row. This is second row. Horizontal lines are called as row. This is second row. This is third row. This is fourth row. So what I want is, if I keep on writing this way, then in which row, then in which row 2023 will appear?
Yes, sir.
Sir,
We
you
discussed.
asked
Sir, it's so
Sir,
properly.
we
easy, sir.
discussed. This
Sir,
is
it's so
module
easy.
1.
We've asked this before, sir.
Yes,
Okay,
yes.
yeah, okay.
Sir, you asked this in module 1
Yes, sir.
and
Okay.
Still
2
two
also.
also.
We
Yeah.
still remember the answer,
2
sir.
times.
Yeah, 88, 88.
And
88
So
column.
let me change this at which position from right instead of left.
Yeah,
The answer will be, this will be different. Okay.
Okay, sir.
Yeah, it's time. Shall we stop for today then? let's meet tomorrow.
Yes, sir.
7:30. Bye. Bye.
Wait,
everyone.
1 second.
Sir,
Thank you,
bye,
sir.
sir.
Bye, sir.
Sir,
Thank you, sir. Bye.
Thank you, sir.
Thanks,